On the quiz, we had a question where we had a non-player character that we said was at position, but then we gave it as a vector. So we said the position was something like, I think it was -3, 4. So when we talk about a vector, does a vector have position? No. So if I say position, but then give the position as a vector, what do we have to think of? We have to think of a vector in standard position with the tail at the origin. I'm sorry? Yeah. So we have the vector here, and what we're thinking of, if we're thinking of a vector in terms of position, we're thinking of the end, right, the head of that vector when it's in this kind of location or in this kind of description, right, with the tail at the origin. All right, so again, remember, a vector doesn't actually have position, but if we use a vector to describe position, then we're talking about the point at the head of the vector with it in this standard position, the tail at the origin. So in that problem, we also mentioned a point x, and the point x was also given as a vector. So what does that mean? A point, again, is a position. So we're talking about a point at the head of the vector 5, 5. Again, though, remember 5, 5 as a vector could have been here, could have been here, could have been wherever. But when we describe that as a position, we're blurring that line between what a vector actually is and what a point is. But when we are doing this in the context of coding, what that will allow us to do is to use one data type to represent both things. We just have to be aware of which thing we're representing at a different time. Is it a point? Is it a vector? Okay, so these actual vectors can be anywhere. We don't really care about the vector at this point as much. All right, then it said on that question that the NPC is facing in direction 5, -2. So I think we called that vector v. And we're facing in direction 5, -2. Now what does that mean? Does that mean that we're facing the point 5, -2? It's down here? No, it says we're facing this direction. So what happens is we're not facing the point 5, -2. From the character, we are facing in the direction of this vector. So this vector is that direction. What are we facing? We're facing that direction. Over 5, down 2. All right, so this is the direction that the character is facing. Now this picture is not to scale, but what are we looking at? We are looking at trying to figure out where the character and the point are relative to each other. Now over here, we had, I'm going to redraw this picture with those vectors. This is the character. This is the point. This is the vector p. This is the vector x. What is that vector right there? X minus p. All right, the head is facing the head of x, so it's x minus p. So we can write down, because these are vectors and not points, because p is a vector and x is a vector, we can calculate x minus p. It makes sense to subtract a vector from another vector. Well, vector p was -3, 4. Vector x was 5, 5. So what is vector x minus p? Eight, 1. Now, I've been writing these this time as row vectors. We could have written them as column vectors, and it doesn't change anything, right? It's just a matter of how we've written it at this point on the board. All right, so we have this vector right here. This is vector x minus p, and this is vector v. So what are we looking at? What we care about, the point over here and the character, the direction the character is facing, we care about that angle right there. If this angle is 90 degrees, what would that mean? Yeah, in this case, the object would be directly to the left of the character, right? Because the character is facing one direction, and in this case, it's to the left, and so it would be directly to the left. Now, just because it's 90 degrees, it could have been the other way, and so in a different context, but at a 90-degree angle, the object or the character looking at the point, it could have been directly to its right. What if this angle, what puts the point in front of the character? What kind of angle puts the point in front of the character? What kind of angle means that the point is in front of the character? An acute, right? An angle that is, well, doesn't even have to be less than 90. It could be anything less than 180 degrees, right? Because it could be anything from left to right as long as it's less than 180 degrees. What would put it behind it? An angle that's greater than 180 degrees in that context, right? Okay, but that's not how we can calculate this. How can we calculate to tell whether something is in front of or behind? We have this vector, x minus p, and we have this vector v. What can we do with these two vectors to determine whether this point is in front of, beside, or behind the character? The dot product. All right, so what do we have in this case? We have 8, 1 dot 5, negative 2. And what is the dot product of 8, 1 and the vector 5, negative 2? So we have 8 times 5, which is 40. And then we add to that 1 times negative 2. So 40 minus 2, and this is 38. So what happens with 38? 38 is greater than 0, which means what? Which means that these two vectors point into the same half plane. So the right angle here, these two vectors point into the same half plane. And so what's the idea? The idea then is that the point is in front of, in some sense, right, is in front of the character. All right. Now, if that number had been negative, what would that have meant? They're facing opposite directions. The vectors are facing opposite directions, which would mean that the point is behind the character. And if this dot product had been 0, it would either be to the left or to the right, and then we would have to look further into the situation to see which one actually applies. All right, so here's the idea of blending or blurring the distinction between a point and a vector. Now, they're not the same, right? You can't add 2 points together. But if we use the vector type to describe a point, then we can think about calculations and we can do things with that. So what is the benefit then for our lab, or how can we use that in our lab? In our lab, we have a grid. Of points, bunch of points, whatever, how many ever. And we can think about their location in terms of vectors rather than just in terms of the points. And then what can we do? Then we can use all of our vector calculation tools that we've created from our vector class to be able to describe what's going on. So for instance, the location of this point, we can describe it just as a tuple with a point. But we can also associate that with a vector. And in Pygame, where is the origin? Top left, right? So if here's our screen, then we could describe that with a vector like this. Well, what's the benefit of that? Well, we have, say, a vector here as well. And if we wanted to find the distance between these 2 points, what could we do? Well, we have this new vector. So let's say this is vector A, and this is vector B that describes these 2 positions. What is the vector that I just drew? B minus A. And so what could we do to find out how far apart these 2 are? We could do, in the case of the grid, we would do the 1 norm. And what would the 1 norm be in this case? Well, as far as the grid is concerned, it would be 2. What would it be on the screen? What would Pygame tell us? Pygame would tell us a different number than 2. Why would Pygame tell us a different number than 2?
Oh, because the reverse y-axis.
Well, what happens? In Pygame, the calculation is going to be how many pixels apart are they? So it won't be 2, it will be how many ever pixels that we're talking about, which would depend on how we constructed things and so on. So what would we do? What would we think of? We think of this distance as, well, we think of whatever that distance is, however we've created our dots, that distance corresponds to 1 in this context. It might be 50 pixels, it might be 100 pixels. I don't know, however far apart you've put them. But it's some distance, and that distance then corresponds to 1 grid unit. So the calculation from Pygame is going to be how many pixels?
Divided by the length.
And then we have to do the extra thing to divide by how far apart are these in order to think of that as actually being 2. Now, we could think of it in terms of 2, or we could, with our calculations, utilize whatever we've used for the distance between things. But what are we thinking conceptually? That distance is 2. What about the distance between this point and this point? How far apart are those 2 points in the grid?
2.
Yeah, that's also 2, isn't it? Because in the grid measurement, the 1 norm, we're measuring horizontal, vertical distance. And again, what happens if we do this in the program? We don't get that actual answer of 2. We have to modify that, scale that appropriately in terms of how far apart the points actually are. Now, what happens in the lab also as we progress, we get more and more points. And so, but we're putting them inside the same region. So what probably happens? The distance probably changes between the points. They don't all stay the same distance apart. You're fitting them in here, and then you put more points, so you have to put them closer together. More points, closer together, possibly. And so this idea is still a distance of 2, but how we determine that they are a distance of 2 will, again, depend exactly on how we've implemented. But what's the idea? That we can not just use a tuple to represent the points, we can use a vector to represent that, and then we can use any vector tools that we need. Now, in this particular case, it's not vital that we do that for this particular problem. But if we start thinking in that way, and I think I've mentioned this a bunch of times now, if we start thinking in that way, when we get to the tasks where vectors really do improve things, we're already thinking in that way of how do you get the vectors to fit and work with what's going on. So this is lab 7 in this case, yes. All right, so just a quick introduction to, if you weren't thinking in that way, knowing that we have to use the vector class for this particular lab, not quite sure how to make that work. This is at least one portion of the lab where we can do that and make that the set of tools that we've built be able to utilize some of it and then get used to utilizing that as we go forward.